Hey guys, today we're going to learn about rational expressions. So the essential question for today is how can we simplify, multiply, and divide rational expressions? First things first, what is simplest form? The most basic way to think about it is that if something is in simplest form, it cannot be factored anymore. This is the official definition, and if we break it down, we learn that we're talking about expressions in the form of a fraction. We're talking about monomials or sums of monomials being in the numerator denominator, and they have no common divisors, meaning that you can't factor them anymore. So simplest form is simply when you are finished factoring. On the left, these expressions are in simplest form. You cannot factor them anymore. On the right, these are not in simplest form. You could take an x out of this one. You cannot have a fraction inside of a fraction. And here you could cross out the factor x minus 3 in the numerator and the denominator, and you'd be left with 2/3. Remember, when you're looking for restrictions, you should always check on the variables prior to and after simplifying. So here, x cannot be 3. If x were 3, that would make the denominator 0. We can't divide by 0. So even though x minus 3 goes away when we simplify it, we still have to say that x cannot be 3, and that is a restriction because originally it would have not worked. You can simplify some expressions by dividing out common factors. And remember, and this is the most important part, you can only cancel out factors, not terms. So for example, we can cancel out x minus 3 because it's a factor. We could not cancel out x and x over here because this x on the bottom is not a factor, it's a term. It's part of the bigger factor, x minus 1. Here's an example for you. Simplify this thing and then state any restrictions on the variables. Well, if you look at it, you'll notice that if x or y is 0, that makes the denominator 0, so neither x nor y can be 0. That's the restriction. And what we do is we start by writing it down, and we just try to reduce as much as we can. So negative 27 and 9 reduces to negative 3. Since 27 is on the top, the 3 will be on the top. X cubed over x to the 4th reduces to x. Since the x to the 4th is on the bottom, the leftover x will be on the bottom. And y over y will cancel out. You can think of it as being equal to 1. It doesn't really matter in the final answer. Negative 3 times 1, or just negative 3 since the y's canceled, is negative 3. On the bottom, x. We can check the restrictions again. Up here we already knew that x couldn't be 0. X still can't be 0, so we have no new restrictions. Here's how you try it. I'm going to wait about 5 seconds and put up the answer. Hopefully this is what you got for your answer. Here's our next example. Look what's going on up here. We have a lot of stuff happening, and we can't really tell, what could or could not be restriction right away. So the first thing that we want to do is factor the bottom. And if you notice, it's a quadratic right here, which means we can use the quadratic formula, or we can factor, complete the square, whatever. We're going to try and factor first. It's going to be the quickest way if we can do that. And sure enough, it turns out that we can. We can factor the bottom into x plus 4 and x plus 2 because 4 and 2 multiply to positive 8, add to positive 6. On the top, we took out the greatest common factor of negative 3, and then it became negative 3. This became an x, took out a negative 3 from negative 6, and that became a positive 2. In the denominator, now we can see, oh hey, if x is negative 4 or if x is negative 2, the denominator will be 0, so those are going to be our restrictions. Last step, let's try and simplify it. We can get rid of this x plus 2 over x plus 2, leaving us with negative 3 over x plus 4 as our final answer. And again, we'll check for restriction. The restriction is again negative 4, so no new restrictions. Here's how you try it. Hopefully when you tried it, this is the answer that you got. You were able to simplify the top, and the way that you did that was first pulling out the greatest common factor of 4, that would have left you with x squared minus 9, 4 times x squared minus 9, and you should recognize x squared minus 9 is the difference of squares. So a squared minus b squared equals a plus b times a minus b. I reduced x squared minus 9 using the difference of squares to get x minus 3 and x plus 3. Here on the bottom, we factored. We can look for restrictions here if x is negative 7 or if x is negative 3. That's not going to work. It's going to make the denominator 0. So those are going to be our restrictions. We can cross out x plus 3 and x plus 3 because those factors are the same, leaving us with the rest of this stuff as our final answer. So 4 times x minus 3 over x plus 7 is our final answer. And again, check for restrictions. X, if it is negative 7, it's not going to work, but we already knew that, so there's no new restrictions. Beware of tricky factors when this is going on. They, the SOL people, they want to trick you. They might give you a factor like 7 minus x. You might think it can't cancel out because you're not used to seeing factors like that, but wait. Think about it. You can rewrite 7 minus x as negative x plus 7. So you're just switching the terms around. You're not changing the value, you're just switching the order. And then if you factor out a negative, because nobody wants to lead off with this negative x, factor out a negative 1, negative comes outside of the parentheses, it becomes negative 1 times x, negative 1 times negative 7 will get you back to negative x plus 7, which can get you back to 7 minus x if you worked backward. This factor you can actually work with. X minus 7 is one that's more familiar to you, and it's totally fine the negative came out. Again, we didn't change the value, we just changed the order. Here's an example where you might see it used. This is what they might give you. On the bottom, you notice that it's one of those tricky factors. We eventually can factor it until it looks like this, factoring out that negative 1, changing the order of the x and the 7. And then we see, oh, hey, wait a minute. I've got x minus 7 on the top and x minus 7 on the bottom. They are factors. I can cancel them out. And when I cancel them out, I get 3 over negative 1 or negative 3. Now let's look at some multiplying and dividing. You're going to follow the same steps to multiply and divide rational expressions as you have done in the past to multiply and divide fractions. So when you're multiplying fractions, remember that you just multiply straight across. So a over b times c over d, a times c over b times d. And when you're dividing, let's say e over f divided by g over h, you find the reciprocal, so you flip the second one, g over h, to get h over g, and then you change the division sign to multiplication sign, and then you multiply straight across to get eh over fg. Pro tip for what we're about to do next, you always want to factor before multiplying when possible. The reason why is that you can cancel out factors and save yourself a lot of work on the back end. So always try to factor first. Alliterative, factor first. Here's an example. There's a lot going on here, but we can totally tackle it. Notice first that the guy on the right, he's done. There's nothing to factor there, so we just really have to factor the guy on the left. First things first, we notice that we have a division problem going on. So we're going to change it. We're going to flip the guy on the right, and we're going to change division to multiplication. Next step, we are going to factor the guy on the left. So x squared plus 10x plus 16 factors to x plus 8 times x plus 2. 2 times 8 is 16. 2 plus 8 is 10. On the bottom, x squared plus 6x plus 8 factors to x plus 2 times x plus 4. 2 times 4 again is 8. 2 plus 4 is 6. If we multiply straight across, we notice that we can cancel x plus 4 and x plus 4. We can cancel x plus 2 and x plus 2, leaving us with x plus 8 on the top and 1 on the bottom, which of course simplifies down to x plus 8. Restrictions on the variables? Well, we look all the way up here. We have x plus 4, And then when we factor the bottom, we end up with x plus 2 and x plus 4. So the restrictions would be negative 4 and negative 2. Last but not least, we have one more you try it. Now with this last you try it, you can see that we have division again. We also have to find the restrictions on the variables. So, first things first. Well, I guess we did the whole thing at once. What you see going on here, we flip the second guy, and we multiply straight across. So 7x, 8y, 21x cubed, 4y cubed. You could multiply 7 and 8, you could multiply 21 and 4, but I'm going to tell you what I do because I think it's easier. I look at 7 and 21, and I think to myself, I can reduce 7 over 21 to 1/3. The 1, of course, doesn't really matter when you're multiplying, but the 3 will be on the bottom. And look, there it is. I can also take 8 over 4 and reduce it to 2 over 1. And again, the 1 doesn't matter, but the 2, he's going to be on the top, and there he is. X over x cubed, y over y cubed. This top x is going to go down since x cubed is bigger. X squared is what's going to be remaining. We took away 1x from each side. X squared will stay on the bottom. Same thing with y cubed. Y cubed is on the bottom. We're going to take y from the top and a y from the bottom. Y squared will stay on the bottom. No matter what we're looking at, we have y's on the bottom here. Then we change to having x on the bottom. No matter what, if x or y is 0, it's going to make the denominator 0 at some point in this problem. So the restrictions on the variables are that neither y nor x is allowed to be 0.